Now let's continue with our illustration 18-54 and do the calculations to determine if the overcurrent device of 15 amps will protect the number 10 THWN copper conductors. Step 1. We'll find the ratio of the transformer, primary and secondary, in accordance with 725.45D as in dog, around page 634 of your code book. Now 240 volt secondary divided by a 480 volt primary, and here it's times the 35 amps from table 310.16 in the 75 degree column for a number 10 THWN copper conductor. When we do the math, it's a ratio of 17.5. So step 2, we want to see if the overcurrent device for the control circuit will protect it. So 725.45D has been applied in step 1. So we go to 240.6A, which refers us to table 240.6A, on page 100 in the NEC. And if we round down from 17.5 to that 15 amp overcurrent device, the conductor has enough ampacity that the 15 amp overcurrent device does protect it. Now, to check our ratio of 725.45D and 240.6A, as well as table 240.6A, along with 430.72C1 for a control transformer on page 322 of the code, we would then take 480 and divide it by 240, 2 to 1. We take the 35 amps again that we selected from table 310.16, column in the 75 degree column, based upon a copper THWN number 10 conductor, and divide that by 2, and we come up with 17.5. So both ratio calculations will verify that the solution that is correct. The overcurrent device for the control circuit is 15 amps, and that complies with the NEC. And that's what this illustration 18-54 is illustrating.